should be done in 2 hours. I think the presentation is probably going to take about an hour and a half.
Okay.
Okay, so my plan for the presentations is just to go through them essentially as they appear in GitHub. That'll be easiest for me to not mess up. If you add your presentation in, it'll probably just get inserted somewhere in here and I might skip you, but I can go back at the end and grab you. So you can just have a sense for when your turn's about to come up by seeing how far down you are on the list compared to where we are. I can see the first team's coming up here already. That's great. I'll get this set up so that you can get started. Can you just upload it instead? All right. Okay. Oh, one other thing. Okay. Sorry. Forgot to mention, so we do have a clock up here. It'll have 3 minutes on it. You can watch that. Once it gets down to 0, it's going to turn red, and you should be done by then. If you're not, please be done very, very quickly, or else we'll just make sure you're done and take the mic away. So it's right up here on the chair. You can watch it yourself.
Okay, we're the table that worked on measurements that lead and follow standards. The next guy is going to need it up, so I left it there. Let's go. Mauro and Fabio, please. Oh yeah, hit the button. Hit the button. What do we do here? This? Here we go.
Okay, the first one is a quick delay sample. The subject is measuring RTT over QUIC protocol. The goal is to reduce from 3 to 2 bits the header space used for delay measurement. We make this job implementing delay sample and comparison between delay sample and valid edge counter, that is the known proposal about this measurement. There is some pros and cons, and there is a website to go in depth on this argument.
Thank you. That was it.
Well done. Okay, I'm Al Morton, and I worked on the crossover between benchmarking and IP access capacity measurement. A couple of things are happening in this picture. Access is moving to gigabit speeds, low latency. We've all heard about that coming for 5G. The benchmarking methods we use in the laboratory are based on UDP, but we have a new robust signaling algorithm that we're trying out in our work, and it's working very well, in fact. Today's access test methods mostly use multiple TCP connections. So we're going to run tests replacing this access link with a calibrated laboratory setup using a test device where we can install multiple software generators, and where we'll set up traffic disciplines, traffic control, queue disciplines to limit the bandwidth and see how well each system measures. So far, the UDP capacity test did very well, and we need to get iPerf working to measure TCP. Thanks.
Hi, I worked on the loss latency trade-off. It's a DSCP code that by which you can mark your traffic as low latency and inform the mobile network. And in particular, the eNodeB scheduler about how to treat your flows that are real time. So, for example, M2M or audio, video, gaming, stuff like that. I did a couple of experiments on an S3 using the LTE module, and I validated the base assumption of the concept, and also evaluated how much you gain from this differentiated treatment of your traffic. But more of this at OtherFC tonight.
Very good. So this is us. Thanks for your attention.
Thank you.
Thanks for setting such a good example. Okay. So, the next one, do we have the docs team?
Good afternoon, I'm Karamichisuka from NTT Communications. Today I'd like to explain about our DOTS interop and our demo scenarios. So again, DOTS represent for DDoS open threat signaling. So it is standardization of signaling for DDoS protection. Then as a working group status, the core specification of DOTS protocol is submitted to ISG. So for publication now, so it is ready to be RFC, I think. But problem is showing the DOTS protocol's functionality, superiority of DDoS protection, so by design. So, okay, how you plan to solve it? So, okay, we did the DDoS attack in our environment. Okay, then here's what got done. From internet, DDoS attack is coming, but actually this is made by ourselves. Then we place the narrow link in our environment. Then our service hosted in these web servers, bottom of the figure. Then one of the DOTS client resides in the one of the web servers. Then we did access via DOTS protocol. Then ask for help about the DDoS attack to the DOTS server. Then it mitigates the attack. Then in the overwhelmed link situation, we think that over 90% packet loss on downstream traffic is observed, but there was no packet loss for upstream. Then we have two independent implementations and different mitigation capabilities. So we tested that and we saw that if they can protect our property. Then here what we learned. In the hostile situation, communication listed here was successful. So in the hostile situation, only trigger mitigation was successful. Actually, we have two channels. One is signal channel, and the other one is data channel. Then the signal channel has a QAP over TLS, DTLS, and UDP. So mitigation request of upstream hostile network can work by design. So it is our findings. But issues are found. So some of supportive functions doesn't work under the attack. So we need to report to the working group about this situation. Okay, this is wrapped up. Thank you for the thank you for listening for my presentation. Thank you.
All right, next up, looks like one of the DNS ones, DNS SD. Great. Just pressing here. Oh, there it is. I think it should present better if I do it as a PDF. Let's get rid of that. Oops. It's kind of slow. All right.
Thank you, Charles. I was here working with Ted Lemon. We had lots of people come by asking us questions. We had lots of productive discussions that was useful. We have new open source code available. there is the latest snapshot of the Apple MDNS responder code at this link, and TED's code for the registration protocol. The two of us got more code checked in this weekend. Right now, the Apple code is a static snapshot as a tar file. I'm also working at Apple getting that moved to a more live public repository. The focus of what we ended up working on this weekend was service discovery for thread networks. For those who don't know, Thread is a mesh network protocol of IPv6 over 802.15.4. It's used by things like the Nest, smoke detectors and thermostats. It's good for low-powered devices. It's a short-range wireless network, so you need a mesh to make it work. It provides a stable network for IoT home automation. When you want your light switches to work reliably, sometimes Wi-Fi is not up to that task. The key thing here is your Thread mesh network has a border router that connects onto your home Ethernet or Wi-Fi. And to make this work usefully, your phone has to be able to communicate with the devices on the Thread mesh. And there's two things you need to do. One is unicast and one is discovery. The unicast stuff ought to be simple enough. The Thread border router uses IPv6 router advertisement to advertise reachability to its prefix. Turns out in principle there are some that ought to work. In practice there are some bugs we have to work out. But that's not discovery, that's just simple unicast forwarding. The interesting challenge we spent a lot of time this weekend working on was how to do the discovery. This builds on the work Ted did on the service registration protocol. The services, the nodes on the Thread mesh, register with the Thread border router. And then the next challenge is how do the clients, how do your phones and tablets on Ethernet and Wi-Fi know that those services are on the other side of that border router? We looked at 4 different ways of doing it. Kind of the simplest brute-forced one is simply to mirror all of that stuff using local multicast DNS. That would probably work, but it's inefficient. If there are loops, then that could be bad. So we'd like to do something smarter. And what that means is the clients talk to the border router by unicast. We looked at 3 ways of configuring that. 1, bootstrapping using MDNS. Secondly, creating a new IPv6 router advertisement. And the third suggestion that somebody else made talking to us, which is why these discussions are so useful, was to leverage the existing provisioning domain router option. We'll be discussing this more at the DNSSD meeting on Thursday. Thank you.
So next up, the WebRTC, RTC Web. Great, Alex. Oh, it's there. All right. All right. It's on.
Thanks. So we got quite a few things happening in parallel this weekend. We have 3 different groups, the usual suspects that participate in the specs for many years. Some people joining the WebRTC discussion from other working group, and people participating because we're in Bangkok and they got the opportunity to. And finally, we had a separate topic that was getting a lot of heat. There was WebRTC media over QUIC. We eventually did 6 different kind of projects, 3 that were more related to the core of the group, 2 that were for students passing by that we integrated into the hackathon by providing them supervision about the first step on how to use the technology, and eventually a discussion about media over QUIC that was more a paper club than a code generating project. We did a lot more tests for WebRTC. That's always helping. Clarifying the test, clearing the queue. I mean, there was 6 big PRs waiting forever, some of them for more than a year, that we managed to merge in. So that was really, really successful in that regard. We did different kind of tests that were more tied to the protocols themselves, so closer to the IETF, especially on the simulcast part that require some synchronization between the information that is passed over the signaling channel and over the media channel. The biggest discussion and the future work to be done at the spec and on the testing is about simulcast, which is the biggest last pain point left to close WebRTC 1.0. Most of the browser vendors nowadays implement that on the browser side, but as they implement it, we're discovering a lot of things on the protocol that is not clear or not tested enough. So we clarified 2 big points today as the expected behavior on the wire of some of those specifications. And we're going to work toward writing some tests this afternoon so that everybody that wants to implement a compliant client will have those tests to test against and know if they're done and if they're done in the right way. So try to write the test first or just before the implementation ends. Both the student groups actually succeeded. The first one wanted to have a first communication system based on WebRTC, both client and server and the protocols to be able to look at. We help them decide which So that's when I speak about the WebRTC SFU that the Mitico team comes and actually unplug the cable, but it's absolutely not related. So, no, but that's okay. MediaSoup is the one we recommended for them, not Mitico in that specific case, because they wanted to do it in JavaScript, right? So that's a JavaScript. Not that, Mitico and Janus is bad. It's a great, great one. Yes, the slide is back. And another student was more interested in a C++ code, and so we drive him through the compilation that can be as close to dark arts as you can go from time to time. At the Paper Club, we focused on 3 different things, and basically the takeaway here is that there are a lot of different groups right now that are looking at media over QUIC from different angles, and there seems to be a separate discussion. So we wanted to try to synchronize as much as possible those efforts, that everybody would be aware of what's going on, so that we don't reach separate consensus in separate groups. So there are actually 3 papers that are going to be discussed over the week that are listed here, of 3 proposals, and we make sure that almost everybody would be aware of them. So that's what we did.
Okay, I2NSF will be next. Okay.
Hello everyone, this is Jaehoon Park from Sungkyuan University in Korea. This time, I believe this is a 5th time I2NSF Hackathon project. So this time we proved there are driven security policy enforcement system I2NSF on top of NFV framework using OpenStack. So this work is an OpenStack project, involved 12 graduate students, 4 professors, and 2 researchers. This project, you can find it GitHub below link. So this is a post. So the goal of this hackathon project, we want to integrate I2NSF into NFV reference architecture using OpenStack. So the first one is a design, how to design I2NSF framework on top of NFV reference architecture. The second one is a dynamic creation of a virtual NSF as VNF for security policy using OpenStack Taker. The third one is a service function chaining, SFC, for traffic steering using OpenStack networking, SFC. So there are limitations and challenges. Previously, we implemented I2NSF mini-net. This time, we want to deploy this one into real world. So the challenge is design, how to design I2NSF element in the NFV environment. The second one is dynamic creation of a virtual NSF in NFV I2NSF, and also SFC. So this is, you can see, Edge reference model. So in order to bring up the VNF stuff, so this is I2NSF framework. This I2NSF user, this is controller, this is a developer manual system, the main control system. And also the network security functions such as the firewall, web filter, and other DPI, other stuff. So interact with the mono stack, we can create VNF stuff. So this figure shows, you can see the left-hand side, we have two. Network service provider manage I2NSF user for security administrator system, and the security controller in charge of all policy management, the translation of a high-level policy into low-level policy to NSF. And development management system is the vendor providing security VNF. So interact with NFV mono stack to create the VNF, also making service function training, configure network switches. So this is the procedure to create security policy enforcement using I2NSF on top of NFV environment. So we can provide the cloud-based security service system using NFV I2NSF framework. So this time we made a topology. You can see left-hand side we have a mono stack. In the middle we implemented I2NSF on top of NFV VNF stack. So we can providing the web filtering service and also time-based firewall service. So the lessons from this hackathon project, we also proved a concept, the main interface is I2NSF. Also, we proved translation for high-level user policy into low-level NSF policy. So also, we proved design and implementation of I2NSF NFV, design, dynamic creation, and service function training. Also, we had hands-on activity using OpenStack. So this is our hackathon portal. So before coming to this project is not two-day project. So we worked 3 months after IETF 102, the Montreal meeting. Our team made 2 times the Korea IETF hackathon project. So we prepared the last 3 months. So my student and another collaboration student worked together. So we made it. So this is appendix. This is open source environment. This is GitHub. We want to release this code. Our IETF, the members can take advantage of our code. We release full source code. We didn't hide anything, so you can take advantage. And also, we uploaded the YouTube video clip to take a look at our demonstration. Thank you.
Okay, great. All right, so next up, Lurk. Okay, great. Looks like you guys are here. All right, all yours.
Hello, my name is Sanjay, and I'm here to give an update on the secure channel for delegation between the CDNs. So what we aim to build here is a standard-based keyless SSL technique that basically protects security credentials by way of a secure channel between any edge server and the key server. And this also decouples operations associated to these credentials into specific cryptographic services. Where this aims to help, essentially, number one, its use case is with respect to delegation of streaming video sessions. So, and of course, without sharing the private keys between the delegating entity and the delegate. And also, there's many different keyless SSL implementations that CDNs have, but this is really focused on enabling the secure channel between the CDNs, one or more CDNs. So protects the CDN's own IP around the keyless SSL, but allows the CDNs to use an external standard-based channel for communications. And these are the drafts that are relevant to this work. At this hackathon, we were focusing on just the handshake between the lurk client, the edge server, and the key server. The flow is there for you to look at it in the details. And a lot more work actually needs to be done, which is in the to-do list here. Specify such as the PRF hash functions, define capabilities. We're actually drawing this work within the work done earlier within the lurk project, so we are kind of leveraging the work from there. But these are the things that we think we need to add on top. So multi-threading is there, adding the capabilities between the client and the server so that the client knows what the server is able to provide. Also, add additional transport capabilities that are listed here. Also a Go implementation. And also we are aiming to have, before the next hackathon, have the TLS 1.2 completed. Here's a quick overview on the right-hand side of the delegation, and then these are the members that worked on the project. Thank you.
All right, fantastic. And next up, public interest. Do we have you folks here? Yep, great.
Which button to go next? Just the arrow. Cool. Great. Okay.
Hello. Our team's objective was to build a client-based tool to measure domain blocking by DOS servers to inform future work and to consider some of the human rights aspects associated with implementation. So I'll hand over.
So our challenge here was really understanding what the impact of the new protocol stack is on measurements, particularly with a view to the public interest, human rights around the world, and to see if we can better inform development of standards here at IETF. We've done this by trying to get running code, implementation, and really understanding what does it mean, what is filtering, what is content blocking, and what is the balance between providers, authorities, and the rights of the individual. And instead of doing this through policy, we've decided to do it through actual implementation work of some of the new standards that are some of them newly specified and some of them are just coming to deployment right now. So during this hackathon, we zoned in on a new area and wrote this from scratch. Gusha was going to explain the implementation. We built a decentralized measurement system that can use DNS over HTTPS to track the availability of certain domain implementations. Thanks to Martin Thomas for the idea from Mozilla, and I'm handing it over now.
So you can go to netblocks.org/tmp/doh to test this. What you can do, so all of this is client-side, all of this will happen from your machine. You can just enter any domain, and we got a list of publicly available DOS servers that are seemingly active, and then you will get results for the different servers. You can compare the responses, latency, etc. And some interesting insights are that, let's say, if you query google.com, you might get different IPs from Cloudflare or Google, depending on their response. And if you see Quad 9, Power DNS, Blar DNS, Secure DNS, they're not responding currently because they don't have the core's header response available on their server. So I this is something maybe the DOE working group can consider. That I don't think this was discussed while DOH was done into an RFC. So it really helps with measurement so that clients don't have to do any modification of their settings before running such client-side tests. And yeah, that's it. Anything?
So this is another part of the ongoing work to do with review of protocols. And this is a table that Niels and others have built. So the aim here is to really bring forward a table to understand where to focus on next with the next generation stack of protocols that will find its way into user agents that billions of users around the world will be using. So this is really a target list. Some of these protocols are already very good in terms of human rights, public interest, but it's still worth going through them and finding out also how they interoperate, how they work together in deployment, and what could be improved. So these were our recommendations. Gushbaz has already gone through most of these. We want to add a should in there somewhere in future in the spec, and reviews will continue. Do check in with the HRPC team also from the IETF. Also, we want to encourage user agent implementations to support measurement that can facilitate the public interest needs. Right now, things like content filters for ads, ad blockers, can sometimes interfere with these processes, especially client-side implementations. So adding some language for that might help. And this is the team that has been here today working on the code and the reviews. So get in touch with them if you want to check in on any reviews. Thank you.
Okay, thank you. And next up, SSH, I think we're saving that for later. Suit? Okay. Let's do this. There we go.
So we worked on software and firmware updates for IoT devices. We had a fairly good-sized group, I would say. We had a couple of newcomers joining us for this event. They brought a special Renaissance board with a secure hardware IP with them, so some new gear to test for us. We also had a few long-time IETF people joining our group, so some new blood and development efforts there. We like hardware, so we tested a lot of different boards, worked on different microcontrollers, not just on Renaissance, but SD microelectronics, Atmel, different products. The flow we worked on and the work we did started as follows. So first, of course, we have to have the development environment running. So a few of us were working on Dockerizing that environment to get everything set up really fast. Then we had to create the manifests based on the specification, which was recently updated. So we had some struggle there with CDDL to get that working, and produce a firmware image, which is then signed. Finally, this image then needs to be sent to the respective boards, and there are obviously many different ways to do so. We used USB, J-Link, and co-op for that, for the different boards. And then a non-trivial task is also to get the whole software integrated into the boot process. So we worked on a bootloader, and as you can see, this is the flash layout of a microcontroller. So you have different slots, and different code regions need to go in different sections. And so we had to work on this part as well. There are a few lessons we learned this time. We managed to go to shop 2 times to get a new power adapter, which we killed during the tests. Apparently, the power is different in different countries, apparently. We figured this out the hard way. We also noticed that every time we come here, we forget something, so we needed a USB to serial cable. We did not manage to brick and kill any development boards this time. Last time, I think we killed 3. So big success for us. Otherwise, this is going to be expensive. We also appreciated the help we got from some of you in the room, and I would like to specifically point out Carsten and Jim, because we had some hard time getting the CDDL to work, and the COSI as well. So they helped us. Yesterday we had a little bit of a down with those. And we concluded that we have to update the specification that we have been working on recently again to fix some of the bugs that we had discovered, specifically on the examples in the CDDL structure. And there's more links in there. We produced a write-up if you really care about the details. Thanks.
Okay, thanks. Yeah, great to see when other people who aren't part of the team are able to jump in and help out. I think that's one of the great things about this is we have so many different experts knowing different fields. Okay, how about Wishy? Oops. Okay. I want that open. There we go.
Okay, hello everyone. My name is Ari Keren. I'm presenting on behalf of the WISI group over here. So WISI is an activity we have had in the Think-to-Think research group now roughly 2.5 years, and we are looking into semantic and hypermedia interoperability. So when we came to this IETF Hackathon, obviously our topic would be on semantic and hypermedia interoperability. And in particular, what we are looking into is how we can connect things from different ecosystems automatically. So with minimum human effort involved, bringing things together and making them work together. There's a bunch of specifications from IETF and other SDOs that were involved. Of course, the usual web and IoT stuff, HTTP, co-op, what have you. Some internet drafts, such as a resource directory. But also specifications from outside. So WebRTC Web of Things specifications were one of the key things we are using. And we're using live with specifications from OMA and IoT schema.org. Schemas and ontologies. So overall, what we're trying to do here is solve these interoperability problems with web technologies and shared semantics. So what we did manage to do, key achievements, we did turn a lamp on again, and we also managed to turn it off, and completely with our code with no humans involved, except for hacking all it together. What we did also have is semantic interoperability for data and many actions between live with MDM clients, a Philips Hue lights, and a Komai-based toaster. Although there were some challenges of getting the last bits of data working, but definitely on interaction level, we were able to work across all of these devices with very simple piece of code. We also did a new thing directory implementation, which also turned out to be surprisingly easy given the good tools we have for these kind of technologies already. And we did improve at least one existing RD implementation, this core resource directory. Being a research group, we wasn't only hacking, we also had very good discussions. We were discussing, for example, how we can add semantics to binary data. So we've been using quite a bit things like JSON and CBOR, where it's relatively straightforward, but then we have things like Modbus or some very constrained LPWAN data formats that are much more challenging. How can we add semantics also to that kind of data and bring them part of the bigger ecosystem? We also discussed hypermedia safety for IoT. So how can you tell that this action is safe or not? And not in HTTP sense, but as in safe, for example, for humans. If I open a window, it makes a difference if it's your home or an airplane that is 10,000 feet high. How can we give this kind of semantics to interactions that machines can automatically use? And also we discussed quite a bit of semantics and engineering principles. What are the kind of fielding principles, if you wish, for semantics? How we deal with things like semantic uncertainty, that you're actually not quite sure if the semantics are the same or not, and how can machines deal with that? And really, how can we make semantics usable? Just like security, if it's unusable, it's useless. And semantics, if they're not usable, they become useless. How can we make semantics much more approachable for developers and kind? Things that we learned, semantics, even though we have been working on the topic for quite some time, it is still hard. It's harder than you think. So what we're trying to do is make it more approachable, make it easier for everyone. It helps to have set up a lot of stuff beforehand, tested stuff beforehand. We're getting better at this. We only spend maybe half the first day setting up things, but of course things still could be improved. And we also did discover a whole bunch of new potential research topics for the Think Learning research group. So having this kind of activity, hands-on hacking discussions going in parallel is very fruitful for discovering topics that should be having a closer look at. Finally, this is our team. We had 8 members. All of them are previous IETFers and have been in the hackathons, but we had also 2 attending remotely. And if you want to see more details on what kind of things we did and what we achieved, you can check out our Wishy GitHub wiki. Thank you.
Okay, next, the DNS team. Great. There you go.
Hi, I'm Peter from the DNS table over there, and we had a nice group of at least 3 different vendors working together, and on 3 different topics. So one was crazy idea to use Yang to configure DNS servers. Second, even crazier, is finally sort of part of aliasing in DNS, and the third is like over-the-top TLS, talking over TLS to authoritative servers. Let's see. Hackathon plan for configuration is easy. Basically, create an API to manage all the DNS servers, right? It cannot be hard. Apparently, the DNS servers are not made for it, so we were exploring ways how to wrap something around existing configuration tools. And it works. It works for NoDNS, it works for NSD, and it works partially for bind, and I think it will in next hour it will work for bind as well. So no roadblocks, but there were some lessons. First of all, changing configuration files is nightmare if you don't have library for it, and of course you don't have it. And so the takeaway is that we as DNS software vendors should work on APIs to make it easier for users, which doesn't necessarily mean Yang, but once we have the APIs, it will be super easy to put Yang/netconf/restconf on top of it. Okay, so that was configuration, solved problem. We know what to do, just the code. Then the aliasing, right? There were some holy wars in DNS op. So guys decided to screw up the standard, do some experiments, and it turns out that if you want to alias one domain to the other without any exceptions and fancy things, it almost works. It breaks it breaks some stuff, but not too much. We don't have time for details, sorry about that. So if you don't cache, it just works. If you start caching, it unfortunately breaks something, but we will talk with other vendors what we can do about it. And the last and most fancy stuff, security. DNS is totally insecure when you talk to authoritative servers, right? And yeah, DO is interesting, but who wants to have HTTP when talking to DNS authoritative server? So Manu came up with an idea, okay, so let's reuse parts of DNS script, and he's basically encoding fingerprint of TLS certificate into name of the DNS server in the DNS record, and it kind of works. So yeah, thank you for your attention. We don't have time for anything.
All right, thank you. And for those of you who, for one reason or another, haven't been able to upload a presentation, you can make a pull request to the GitHub project. Whoops, wrong one. And I'll merge that in. I can't get to my email right now easily to to do it any other way. Yang catalog. Great. You got back early.
Okay, so good afternoon. My name is Eric Vink, and I'm presenting in behalf of the team which is on the table there, what we did on the yangcatalog.org. As you probably know by now, yangcatalog.org is a website where you can find all the Yang models from different vendors and from the IETF, obviously, but also Broadband Forum and others. The reason is that we want to allow easy search, discover connection between the Yang models, and so on. So it's really key both to develop as well as to use Yang models. So it's not only used by the IETF, but also by operators, for instance. It was running incremental improvement for many years, and at some point of time, it was even running on AWS with IPv4 only. So that's where I should hear woo, because it was v4 only. So we move it to another server, which is v6 and faster and everything. And we try to change and improve all the code, make it starting automatically, and so on. In the process, we hope that we did not break too much, but of course, we are engineers, we break a few things, right? Not on purpose, but anyway. So we needed to test here the API, the GUI of the web servers, as well as data consistency, because that's important. So what we have done here, found a couple of bugs, fixed a few of them, and very broad range. For instance, William, which is here, found that some pages were bad choice of colors for colorblind people, so we need to change the color, something I learned, okay, for me. And other stuff like, for instance, on SQL, you cannot do an insert with more than 1,000 value because it takes too long and it disconnects, for instance. All the code now is purely in open source. So you can go to this GitHub and download all the code, including the static pages, and the way to do those kind of graphs that shows the connection between all the models there. The team here is basically William from Broadband Forum, Eben from Juniper, and three guys from Cisco, Benoit, Mr. Yang, Rashad, and myself here. You can test, report by email, or open issue in the GitHub. That's perfect. Again, we try to make it faster, replacing PHP by Python and the like, and replacing SQLite by MySQL, which is a bit better. Next progress, for instance, to use a Mongo database for the full text search. So if anybody knows about Mongo database, I am more than happy to listen to you. Okay, test and report. Thank you.
So what do we have next? LPWAN? Oh, thanks. Great. Okay, thanks. There you go.
Hello. So this work relates to the LPWAN working group, where we define a compression, header compression and fragmentation protocol called SCHC, hence the chicken we have on our T-shirt. The work we wanted to do here at this hackathon was twofold. One was rebuild a new project structure on GitHub from the ground up, because we had various pieces of codes from previous hackathons, and it was getting a bit confusing. So we wanted a clean project, and we chose MicroPython as the basis for all our implementations. And the second objective was to implement a new fragmentation mode that has been recently introduced in the draft. So we wanted to define the code architecture, the interfaces, the modules, very cleanly set up the GitHub project, the tools that allow people to download the micro-Python environment on computers so that everybody can run this code easily. What got done? We had a few newcomers to our table again this time, which is always good, which we welcome. So we did a little bit of education on what QUIC is about in general, and also this new hack on our fragmentation mode that has been defined over the summer. And then we worked on this new code structure, repository, architecture, interfaces. The QUIC has a notion of profiles, and so we needed to define what a profile is, and using a JSON representation. We wrote the parser code for those representations, and we also wrote the fragmentation and reassembly code for the new mode, at least a large part of it. And we did initial testing of this new mode, so running code. What we learned, well, again, every time we have new people come and read the draft with a fresh eye, they usually spot, editorial mistakes or things that could be better explained, which is always welcome. We also, the implementers spotted one missing must statement. There was an assumption, hidden assumption, and we need to make it explicit so that the protocol is correctly described. So this is a very important result of this hackathon. We discussed various possible implementation strategies, and we increased our confidence in this new mode that we're going to present to an industrial alliance in 2 weeks. And also, since the working group is going to recharter at this IETF meeting, this hackathon has brought new ideas, a new definition of pieces of work to be put in a charter. So this was the team, 10 people at the table, 9 locally, 1 remotely, 3 first-timers at IETF and Hackathon. And again, the link to the GitHub repo and wiki and everything, documentation, everything this time at one single place. Thank you.
Okay. Let's see what's going on here. All right. Looks like my network is back. That's good. What's this one? The TCP AO group. I forgot where you go. Oh, that's right. You're right there. Yeah, there's a few of them that are remote. You can do, yeah, I think it's easier with those.
Okay. Hello, I'm Brian Wise for the TCP-AO team, and this will be relatively short because this is a new group that we've just started working this week. And what is TCP-AO? It is a TCP option. It's used by routing protocols primarily, and it's used to provide integrity protection between a pair of routers where they don't want to use IPsec or TLS for some reason, but TCP-AO provides a nice integrity protection, including protecting against TCP reset attacks. So there's a pair of RFCs that were published, about 10 years ago. One of them is the protocol, the other one is the crypto algorithms that you would use with that protocol. It replaces an older, very old TCP option called TCP MD5 that I think was Trina and Lee as the authors. And I think we all know that MD5 isn't considered safe to use in this sort of thing, and it wasn't 10 years ago either. But it turns out we don't have a lot of implementations, and this is becoming more and more of an issue with routing vendors and operators, or maybe I should have said with operators, and then it becomes an issue with routing vendors. So what we have started is a kernel implementation, Linux kernel, as a reference implementation, and to try and kickstart some additional commercial work on this. So our goal was to begin that work and to also do some work with TCP dump to make it easier to diagnose what's going on. And if we had any router implementations, to do interop testing. Okay, what we did do is we did start on the kernel implementation, and we did some basic work there with, as you have to start with, data structures and how to set sock op work and these sorts of things. And we have some initial, we do have a GitHub set up that with initial kernel and then a application header file that would be used by applications. So this is our preliminary work that we'd use during our development. And we do have a start on a TCP dump implementation that will take the key material and then be able to tell if it's properly formatted. So what have we learned? Well, this is really complex for a TCP option. And so that's probably one reason we haven't had a lot of implementations, and there's been a concern about it. So we're hoping to work through those issues and remove some of the barriers to entry there. In particularly, TCP/IO doesn't just, you don't just define a traffic key, you define a master key, which then is used to generate traffic keys, which is definitely a better level of security than, for example, we had with TCP MD5 for King, but it is much more complex. And then there's also a built-in rollover mechanism, which is very important, but that does give you some interesting design considerations about how to deal with those from the application level. And so we've concluded that there is going to be implementation guidance necessary. We just don't know what it is yet because we're just in the beginning. So there's 3 of us that have been working on the team. Vlad has been from University of Bucharest, I think it is. He has done most of the coding here, and he and I have done some development on that. And Tero's been working on the TCP dump work. Thank you.
So let's see, where are we? So TLS 1.3. I did skip over some presentations because they're going to be done remotely through Meetecho. TLS 1.3 is, oh wait, they're later, sorry. They're one of those remote presentations. I may have actually accidentally skipped over some other ones. I'll try to go back to them, or you can let me know if I skipped over yours, and we'll go back to yours later. That's the template. We don't need to do that one, although it's a really great template. Okay, OA, sorry, IAO. Can't say it. What's the name of your project? Thank you. Can't talk and click at the same time.
Hello. Okay. Hello, everyone. I'm Tianran Zhou from Huawei, and we have a group of people over there, and we practiced on the In-situ OAM protocol. Our plan is to align the latest draft with the VPP implementation, and we also want to generate a Wireshark tool to dissect IOM. After 2 days implementation, we set up the VPP development environment, and we reviewed the latest draft carefully. Several comments are discussed and sent to the mailing list, and we checked the changes on the specification and updated the implementation. Finally, we created this virtual network we use two nodes, two network elements to verify the behaviors on the ingress node and the egress node. And here's the result. We use IOM header to take the node ID and the namespace specific data at every hop along the path. And here shows the data collected at the last node. Although this is a simple project, I think we learned a lot from this simple project. We know how to develop and contribute to the IOM implementation in VPP and FIDO, and we have detailed understanding of the IOM data draft, and we know how to develop Wireshark dissector for protocol extensions. We have a diversified team. Members include people from Cisco, Huawei, China Mobile, and the individual as well. I want to give special thanks to Svesa for her detailed technical support for our team. And we want to continue this activity. Next hackathon, we are going to align the implementation with the latest draft. And we also want to design the IOM encapsulation for SRv6 and MPLS. And that's all. Thank you.
Okay, thank you. Let's see, kill that. Okay, next up, I just uploaded this one, the Swift codec. Yep. Great.
Thank you.
All right.
Hello, this is Vincent. I want to talk quickly about the Swift codec, which is a brand new hackathon project. So Swift stands for sliding window FSC codes. This is something that could be useful to recover from packet losses in a transmission. And it's not the first FSC erasure code that exists. You may have already heard about Reed Solomon, LDPC, and Raptor codes. So that's, however, something completely different because it works with a sliding window. And it does make a big difference when you are dealing with real-time flows because it helps you reduce the latency that is added by FEC encoding and FEC decoding. And there is also a strong link with this coding for efficient network communications research group and WCRG, as well as one such FEC schemes RLC that I'm working on in the context of TSV working group. So the goal of these hackathons were twofold. First of all, we wanted to design a reference codec, open source, free codec, and because no things exist with exactly what we want to achieve. There's some existing commercials thing, but nothing free. And we also want to help people test and experiment and hopefully help adoption of this technology. The second goal was to challenge our API internet draft that describes how to interface, how to use those codecs. So it was one of our main objectives. And finally, we had also a third objective, which was not in our initial goal, which is to see if our FEC and network coding for dummies document is working well, because I had a newcomer, a new IETF comer, so brand new to IETF, so it was also a good opportunity for me to see if this document is fine from this point of view. I'm quite satisfied by this hackathon, first of all because we fixed a few mistakes, so we simplified a little bit some functions, added a new missing function, this generic API document, so that's something very useful for me. We also laid out a brand new repository on GitHub for this codec, so that's also something great. We are starting from scratch, more or less. We reused some existing code, but more or less it was a brand new project, GitHub project. And we made a lot of progress on the encoding side. We had little manpower, so didn't manage to go as fast as I would have loved, but anyway, it's a good start. And we will leave a lot of things for next IETF Hackathon. So that's all. Well, don't hesitate to ask me if you're interested. I'm looking for manpower for next Hackathon. As you can see, it was a very small team. Thank you.
Okay. Let's see what we have up next. That one, wait a minute, we did that one. Multicast ingest.
All right, thanks, Charles. I'm Jake Holland, and my project was a multicast ingest platform. The problem I'm trying to solve is we have multicast today, but we don't really have it between domains very often. In Internet 2, you do see it some, and in fact, some of the traffic I'm pulling today is coming from there. The NSF runs a video feed there. And Lenny from Juniper has put up a publicly reachable relay, which I'm using to ingest some of the traffic. I'm running the free-range routing stack in 3 different routers, and the client devices just do a join, propagates through this little network, and starts pulling the multicast in. And one of the open problems is determining which relay you should pull from when you're using AMT to transport the multicast over unicast to cross a non-multicast network. So there's a draft we're going to be discussing in Mbondi, and that's the DNS portion of this. When the join happens, then there's a DNS lookup. The lookup indicates which relay you should use for that source traffic, and then issues the join. So the hackathon project was to bring that up, make sure it works, and that's running okay. So I will be talking about it in Mbondi on Tuesday. Please come support it if you think this is important. I'll also be here at the hack demo, and you can reach me. You can see the configs I use to bring up the network, and reach me with this contact. Thank you.
Okay. QUIC. That'll work. Oh, okay.
You're not supposed to read this. So in the back table, the big table, we've done what we always do, which is an interop testing of a bunch of QUIC implementations that are implementing the current, what we call implementation draft, so the current IETF draft that we've all agreed on implementation, which is -15/-16 at the moment. 16 is identical to 15 except for textual changes. So the basically servers are horizontal, clients are vertical. If a cell is white, there was no attempt to interop. If a cell is not white, we try to do something. If it's greener and has more letters, more stuff worked. If you think back maybe a year or so, we were a whole lot greener back then, but there were 2 reasons for that. We had a big reorg in terms of the handshake mechanism that caused some delay, and we're still not fully where we were in terms of that. And we're now actually also testing a whole bunch of more things. Back then, I think we tested 4 things. Now we're testing like 7 or 8. So that also explains why we're not sort of dark green. But it looks pretty good. I think we have like, you see a bunch of implementations there on the right that haven't really participated this time. But we have like 10, 12 stacks that are active at the moment, which is pretty good. So thanks.
Okay. The SD-WAN service model, I see you guys are here. Download that.
Hello, good afternoon, everyone. Yeah, my name is Xin Wu. The project we proposed is SD-WAN service model mapping. Actually, we see a bunch of the service model has been developed by the IETF. They can be used to define L1, L2, L3 service, and we also see a large number of young data model. We call the device model that can be used to realize the service. So the basic idea is to do the service mapping between the service model and device model or configuration model to facilitate the service delivery. So the goal we set up is verify the SD-WAN service connection, set up modification and deletion using the open source platform we call the ONAP open source platform. So the ONAP open source component or tools we are using, such as SDNC, they actually is open source ODL controller component. We also leverage like SLI, service logic interpreter, and Swagger, and MySQL. And MySQL can be used to save some artifacts. And we also leverage long rate direct graph. This kind of tool can be used to write or compose the workflow. So this is the key for the service model mapping. And a Postman-based API, because we don't have a service orchestrator, so we use Postman to simulate the SO to inject the user input to the SDNC. So this is a scenario we set up for our project. We have one SD-WAN controller to manage 2 network devices in two SD-WAN sites. So on top of the SD-WAN controller, we have SDNC. These serve as a multi-domain service orchestrator. So this SDNC can instruct the SD-WAN controller to program the network device. So we use Postman to inject the input to the SDNC, and we can use a custom model as a template. And SDNC actually will use the direct graph builder to do the mapping between the service model and configuration model. So this shows how the service model working. Actually, we actually have a custom model. They can actually inject this user input. And we have a direct graph builder. Actually, they can actually decompose all of the service parameter into the configuration parameter, and they actually can realize the service. Here is the northbound interface API. We actually we developed used on the top of the SDNC. Actually, we developed 17 API in this meeting, and on the right side we have JSON data actually show how the user input can be expressed using this JSON data. The next is service modification. Actually, the basic idea is if you want to make a service parameter change, it doesn't need to have impact on the underlying the configuration model. So we use a DG builder to actually hook the service API with the resource API, and you make a change to the service API, they will be automatically updated in the DG Builder grapher tools, and they actually can be loaded into the SDNC controller. Also, they can populate in appropriate network device. So what we have done actually, we actually leverage the ONAP CCVPN open source project, and they already developed SD-WAN service creation and modification API. So we leverage this API. We also introduce Postman API tools, APIs, and they can actually simulate the SO input, and they can actually help us to design the API, test, monitor, debug, or document the API. What we have known, actually, we think API actually can be derived from the device model, but also can be derived from the service model. So service model is very crucial for the automation. So we introduce this service model mapping. Actually, this is something very important for the automation, since we decouple the service model from the configuration model or device model. So this allows more faster service innovation. And we leverage some open source tools. They can provide a very handy tools. Actually, they can be used to do the service model mapping, and they can provide the lifecycle management of the API to accelerate this service delivery. So also the experience we learned, actually, we should listen some feedback from the open source community and work together with open source people. Actually, this time we get together with some open source people from the ONAP, and we have better understanding of how service model workers using some open source tools. So this is our team, and so thanks for them to join us, and we think, more collaboration between the open source community and IETF is needed. So that's all. Thank you.
Okay. Teep.
Okay, so there's a pull request that fixes this slide, but I'll use this slide to mention this report is from the Trusted Execution Environment Provisioning Working Group. This is our first hackathon report because our group size has been doubled since last hackathon, which means we're now up to 2 people. And so a trusted execution environment, if you're not familiar with it, means that there's a particular processor or context of a processor that can execute trusted code, that code has to be signed before it will actually execute in there. So it's not where you put your normal applications. Similar to, there's a potential part of this slide that you can't actually see what's going on in that part of the slide, right? That's like a trusted execution environment behind there that's hidden, okay? What we're trying to do is we're trying to provision the code and the configuration into that trusted execution environment, okay? How do you put stuff behind this image that you can't actually get to, right? That's the context. Okay, so our plan, there's a spec which is referenced there, the Open Trust Protocol. That spec is still relatively early in development, meaning that the working group has been working on the architecture document. So there are potentially various implementation bugs or issues in the document, and that's what we set out to figure out. So to do that, we first had to implement the various dependencies inside of a trusted execution environment, which means that we had to take like open source code for JSON web tokens or JSON web signatures, encryption, and keys, and port that code to run inside of a trusted execution environment. And so that's the first test that we did that was accomplished. And so we started from the open source latchset Josie code because that was open source C code. And so we forked that and implemented that in a trusted execution environment. Secondly, we started trying to implement the first message exchange between 2 separate implementations. And we ran into some issues in the internet draft that said that it was underspecified in terms of the transport. And so at the table, we actually worked out what we wanted the transport mechanism to be, how the connection establishment worked, what we wanted to go into the spec, and we started implementing that. And so we specified things, or we decided on things that were not in the document, like using HTTPS with application JSON was what we settled on for the hackathon. And so we designed, because it wasn't in there, and implemented the first message exchange. A number of messages are in the document, but how you get started, there was a message that was missing. And so we worked through that and defined it. And again, the idea is complete, but we came up with a proposal between the implementers that we think we know how we want it to work, and so we'll take that back to the working group. And lastly, we had a discussion but didn't actually get around to implementing lifetime management. How often do you check back? So the OTRP protocol communicates between a client running inside of a trusted execution environment on a device and a server that takes care of signing code and so on. And so how often does a device go and check back with a server to say, hey, you got any more policy for me? Any more changes for me? How often does that happen? So we talked about and decided on what goes in the spec, but didn't get around to implementing that. And so again, here's our 2 team members, which is double the size of last time. So thank you.
So if you keep doubling each time, we'll have to get a bigger room before you know it. Okay. Okay, let's see. So now we have a few presentations that are remote. And I'm going to see if I can get this to work. And are the, oh man, I need to find, do I really need to get my registration ID? Logan, are you able to speak and are we able to hear you? That'd be the first question. I need to log into this probably first. Is anyone from Miteco here? I don't know if we actually have this set up and working. Okay. So, are there any presentations I skipped, people in the room? Really? I got them all? I can't believe that. Really? No one uploaded a presentation I accidentally skipped over? And you still want to present? Okay. Hold on just a minute and let me see if I can get this, get the Miteco thing working and if we can get the remote presentations done. All right, so I can hear you guys now. Logan, is that you? Can you hear us?
Hi, Charles. Can you hear me?
Yes, I can.
Is the quality good?
It's okay. There's a little bit of feedback at times, but I think what we're going to have to do is I'm going to have to get signed on to the Miteco here.
Can you help us with the slides?
Yeah, I think so.
So just let me know when I can start.
Okay. I'm just trying to get logged into Miteco. Okay, can we still hear you? I think so.
Yep.
Actually, are you able to drive the slides from where you are?
No, I'm not able.
Okay. Okay, so the first one, you have one for TLS 1.3?
Yes.
Okay. I have that up on the screen now. I'm on the title page. So let me go to slide 2.
Yep. Yeah, let's go.
Okay.
So, thank you. So on slide 2, so our plan during the hackathon was keep on working on TLS 1.3. So we had to, again, read parts of the RFC. The second part was about implementing TLS 1.3 using different libraries. And the third part was about adding first handshake authentication. And the fourth part was about middle box compatibility mode. So let's go to the next slide. Okay, thank you. So what we got done was adding TLS 1.3 support in the core of PHP 7. The pull request was sent. But next two projects were a bit more complicated. So both Nmap and, so let's start with Nmap. So in the case of Nmap, what we have is a TLS, minimal TLS stack within Nmap. So it had to be modified so that it can post TLS 1.3 traffic. So what got done was the client hello pod and part of a server hello pod, the parsing. And the third project, which is a bit more complicated, was about implementing a TLS 1.3 stack in C#. So the client hello pod was done, and it's able to get any server to return a server hello. And the fourth part was about adding middle box compatibility mode, so you can disable it or you can enable it from curl just from the command line over the API. So let's go to the next slide.
Okay.
So on the next slide, TLS 1.3 for curl with the GNU TLS as backend was done and merged. And for post handshake authentication, we did one for Nagios and one for wget2. The reason being that Apache server supports post handshake authentication. So can you go to the next slide, please?
Okay, slide 5.
Yep. So what we learned, basically listened from feedback from upstream developers. In the case of curl, they responded immediately. They were helpful with GNU TLS and the middle box compatibility mode, and it's in progress of being merged. Reading the TLS 1.3 RFCs, and it's a really big exercise in patience. The way we found to actually understand how it works was using a pen and a piece of paper and just trying to write the different flows as it goes. So client hello, server hello. And Wireshark is a really great debugging tool that helps us better understand the protocol. So next slide, please.
Okay, we're on it. I'm on your
So thanks to I can see it here. So thanks to everybody who was there from Mauritius. So Kodaren, Jeremy, Muzaffar, Rahul, Nathan, and myself. And we have the GitHub repo where we put all our code. And again, thanks to Charles for helping us coordinating remotely as well as with the slides as well, and the Miteco team as well. Thank you very much.
Okay, you're welcome. All right, and you have a couple other presentations. Will you be doing all of them, or will someone else be doing the others?
So two more people are going to come. So we have two more presentations. One is on SSH, and the other one is on HTTP 451.
Okay. Let me find you said one on 451?
Yes, 451.
Okay, let's do that one first. Okay, I'm on the title slide. I'll move to slide number 2.
Okay, thank you very much. So Keshav is going to come next. Slide number 2. Slide number 2.
I'm on slide number 2.
Hello everyone, my name is Keshav from cybersecurity. So our team's objective was to implement HTTP 451 along with RFC 725 for various web frameworks and CMSs, which will increase transparency and visibility for censorship on the network. On the next slide, please.
Okay.
So what we got done was we developed a Django module as well as Drupal 1, which implemented HTTP 451. Additionally, we have added the geolocation feature to further enhance the HTTP 451 implementation. Can you go to the next slide, please? So what we have learned during this IETF Hackathon, mostly with geolocation blocking, was to also cater for traffic coming through proxies. One struggle we faced was with testing geolocation block feature in the modules, but eventually those were corrected by using HTTP X-forwarded for headers. Can you go to the next slide, please? So our number team members were was Ifamero, Vidish Ramdani, and myself. The next slide, please.
Okay.
So we would like to thank all members from cyberstorm.mu who worked on the various projects, including SSH, TLS 1.3, sponsors of IETF 103 by Cisco and Huawei. We'd like also to thank Tamara and Charles, and also Mitigo. Thank you very much. So I'll pass on to your meeting for the next presentation. Thank you.
Okay, thank you very much. Okay, and now we'll do the SSH one. I just need to find it and download it.
Okay.
Where is it? here it is. Okay, we have it here. I'm on the title.
Okay, hello everybody. My name is Nitin. I'm from the Cyberstorm team. So for SSH, we work on the deprecation of S4. The main goal is to get S4 out of SSH. So next. So we work on a brief internet graph from Mauritius, and we are all from the Cyberstorm.mu team. To be able to get OSI4 ciphers, Wireshark was used and can be recognized in the key exchange section. The project's concern or NetSSH. Can you just move the next slide, please?
Yes. So I'm on slide 3.
So the project concerns, So the project concerns or NetSSH, a re-implementation of SSH. PR was sent as well. We also have to work on a Java secure channel, which is a Java implementation of SSH. So pull request sent, an email was sent to the developer as well. One of the most interesting thing about NetSSH is that we noticed that the same library is used in VMware, in the tungsten replicator repository. And right now it has OSI4 ciphers being used. And once the commit will be accepted there, so we will, it will be backported to VMware as well. So tungsten replicator is used for data replication for MySQL, Oracle, and also Amazon Web Service. So some difficulties encountered while using OSI4 is about the tests which had already been automated. So we have to modify the test as well. So the Java library was compiled using Apache Arc. A considerable amount of time was invested in it. I should admit that Wireshark was our savior to chase OSI4 out of SSH. Can you just move the next slide, please?
Okay, slide 5.
Yeah, so this is our team. We are all from Mauritius. So we had lots of fun, even had a Halloween party in the pool. So we like to thank everyone. Okay. And Charles from IETF and the Mythical team as well, and Kamara to draft the OSI4 draft, as well as Logan and Riveton contributed to the draft as well. So thank you everybody, and have a nice time ahead.
All right, thanks you, Nitin. Okay, so I think that's it for all the presentations. Anyone I missed?
That's all.
Oh, okay, thanks.
Yeah, thank you.
So now, just a reminder to, now it'd be time to do the voting, and I'll leave this up for a few minutes so people can go and do it. The MeTecho poll, if you go to the wiki and you scroll down a little bit, it's right after the agenda. You'll see this, doodle for voting. You click on that and you can go and sign in and place your vote. You can only vote for one project, and we'll give maybe 5 minutes for people to go do that. In the meantime, the other thing I wanted to remind people of is that we do have a couple things going on continuing on this week. So we have the Code Lounge, which will be here. This room will be turned into the Code Lounge. You're welcome to use it all week. If you want to keep working on your projects or anything related to running code in the IETF. And then very importantly, I know these presentations were short and you couldn't go into too much detail and we didn't really have a forum for a question and answer. But that's what the Hack Demo Happy Hour is really for. So that'll be tomorrow. Again, it'll be in this room. It'll run from 6:30 until 8 o'clock. There'll be some snacks provided. I'm not sure if there'll be drinks provided or if it'll be a cash bar. Don't actually know how that works. There'll be beverages available one way or another. Based on what I've seen, I'm sure there'll be some good food because it seems like there's tons of food here. But the important thing is you do have to reserve space there. So if you want to do that, click on the schedule, the link here. You can see everyone who's already registered to do it. We have one so far, so please add yourself to this table. We really need to have that so we know how to set up the room and we make sure we have enough tables and these boards for people. So please do that before noon tomorrow, and then we'll have space for you here. Any questions on that? All right. Anyone having problems with the doodle poll? All right, I'm going to unplug so I can vote.